All right, if you go to today's module, day 2, I won't go through the PowerPoint. It's very dry, just kind of showing static code examples in PowerPoint. So what I do instead, I use these live scripts. So you can download this, and it's a MATLAB. I'll show you in a second, but it's an executable MATLAB file that also has text and images and equations in it. So it's really good for presentations. All right, so you can download that, open it up in MATLAB, and go through it with me. All right, so arrays. What's an array? Just a collection of numbers. Actually, it can be other things besides numbers, but for right now, we'll just say numbers. And it can be one-dimensional, in which case we call it a vector. Or it can be two-dimensional, in which case we call it a matrix. So here are some examples of creating vectors. Right, the most explicit way to do it, you literally just list all the numbers in square brackets. Okay, so that's what makes this a vector or an array. So for example, let's say you're tracking your weight. You're in a weight loss program and you want to track your weekly weigh-ins. So you just list all those numbers. And of course, we'll talk about plotting, I think next time actually, or no, I think on day 4. But the first step to do plotting is you have to put the numbers into a vector. And this is real, by the way. I actually did this a few months ago, and these were my actual weigh-ins. Or let's say you're keeping track of your weekly cycling or running miles or whatever sport you do. Okay. So notice you can separate the numbers by commas or spaces, either one, it's equivalent. Right? So with these live scripts, you click Run Section, and it'll run just this block of code. All right, so this is nice because you could have presentation text, images, equations mixed in with live blocks of code. All right. So you see it just comes out as an arrangement of numbers. In this case, they're being displayed horizontally, so we call this a row vector. Now notice the two vectors, the numbers are being displayed differently. In this first one, there were a couple of numbers that weren't integers, they had decimal points. Therefore, all the numbers in this vector have decimal points. So they're what are called floating point numbers in computer terminology. In the second one, they were all integers, so they're displayed without decimal points. And they're actually stored differently inside the computer. And there are occasions when you have to think about that fact, because you do treat them a little differently sometimes, depending on whether they're floating point numbers like this or just integers like this. All right, so that's if you just have a set of numbers, you want to explicitly list them all, put them in a vector. More often, what you want to do is create a vector of evenly spaced numbers, like when you're doing plotting and you want to set up the grid of x values. So one way to do that is with the colon operator. You put 0, well, in this example, 0, 2, 11 means create a row vector, starting with 0, going in steps of 2 up to 11. Now, it may have occurred to you that doesn't work out evenly. So what's going to happen? Well, it just stops at the last one that's less than or equal to 11. Okay, so this won't give you an error or anything. It'll just go up to, in steps of 2, up to the last one that's less than or equal to the stopping value. All right, so you just have to make sure you keep the order straight. It's starting value, step size, stopping value. Another way to make a uniformly spaced vector is with the function linspace. And this is a little different. This is when you know how many elements you want the vector to have. So this says, give me a vector starting at -10, stopping at 10, and that has 5 numbers in it. And MATLAB will figure out for itself what the step size has to be for that to work. All right, it turns out in this case, it's a step size of 5. So you go from -10, -5, 0, 5, 10. All right. So if you know what you want the step size to be, you can do it this way. If you know how many numbers you want the vector to have, you want MATLAB to figure out for you what the step size is, then you use linspace. All right, so these are, as I said, they're called row vectors because they're displayed horizontally. You can also make what's called a column vector, and it'll be displayed vertically. And the difference in the syntax is you separate the numbers by a semicolon, or you can just put them on separate lines. Either of those will make this a column vector. All right. Now, the obvious question is, what difference does it make? When do you use a row vector versus a column vector? The answer is, unless you're doing linear algebra, like matrix vector multiplication, it doesn't matter. And so for most of what we're doing in this class, it doesn't matter if you use row vectors or column vectors, as long as you're consistent. Because next time we talk about how to combine vectors in calculations, you have to be consistent. If one's a row vector, they both need to be row vectors. But it's only when you do linear algebra, which we're going to do a little bit of on the last day of the class, then it makes a big difference whether you have a row vector or a column vector. All right, so that being the case, well, what if you have a row vector and you want it to be a column vector or vice versa? That's okay. You can easily change it from one to the other using the transpose operator, which is just an apostrophe. All right, so I had this vector cycling miles, which was a row vector. I decided I wanted to be a column vector instead, so I take its transpose like so by putting an apostrophe afterwards. Okay, or I had the ages before as a column vector. I can take its transpose and turn it into a row vector. All right, so the only time you would probably use this in this class is if you had two vectors and you needed to do an operation combining them, and one was a row, the other was a column, you need them to be the same, so you take the transpose of one of them. And you can do this with the other techniques using the colon operator or linspace. Okay, you can, excuse me, if you're going to do it with the colon operator, then you need to put it in brackets. Up here, you notice I didn't put it in brackets. It's not necessary. You can, it doesn't change anything. But if you then want to take the transpose of it, then you need to be able to put it in brackets. Or the same with linspace. You can do linspace and then take the transpose. All right. All right, so let's just take a couple of minutes to do a couple of practice problems here. I'll give you like 3 minutes to do these. Just a little practice at creating some vectors.